Hi guys, so let's have a look at exercise 14.4. That's exercise 14.4, question 13. Okay, so a cylinder is manufactured to hold 1 litre of oil. 1 litre is equal to 1,000 centimetres cubed. Find the height of the can in terms of the radius. Okay, so what do we know about the height and the radius? Well, we know that the volume is equal to pi r squared h. This is the volume of a cylinder. We know that the total volume of the cylinder can is equal to 1,000 centimetres cubed. So 1,000 is equal to pi r squared times h. We now need to write the height in terms of or the radius. This gives us h equals 1,000 divided by pi r squared. Let's keep it in terms of pi. Okay, so part 2 asks us to find a formula in terms of or for the total surface area of the can. Okay, let's see what shapes make up the total surface area. So the total surface area is equal to 2 circles, so 2 times the area of a circle, plus the area of a cylinder. Let's substitute in the formulas that we know for the area of a circle and the area of a cylinder. Our total surface area is equal to 2 times pi r squared plus 2 pi r h, the area of our cylinder. We now want to write this simply in terms of or. So I need to substitute in my equation for height, written in terms of or, for h. This gives me 2 pi r squared plus 2 pi r times 1,000 all over pi r squared. Let's tidy this up. This gives me 2 pi r squared plus 2,000 pi r all over pi r squared. Cancel out our common values on the top and the bottom. And we're left with 2 pi r squared plus 2,000 all over r as my total. Okay, let's have a look at part 3. Find the dimensions that will minimize the cost of the metal used to manufacture the can. So we want the dimensions, so we need to find what is the radius that will provide the minimum area of our can. So anytime we're looking for the maximum or minimum value, we need to derive our equation and put it equal to 0. So we have our equation for the area as 2 our equation for the area is equal to 2 pi r squared plus 2,000 all over r. Okay, so I want to find dA dr. I'm going to derive my area with respect to the radius. First off, when deriving my equation, I'm going to move my value for r, which is on the denominator, to the numerator to make it easier to use the power rule. I can move any value from the denominator to the numerator by changing the exponent to a negative value. This gives me 2,000 times r to the negative 1. From here, I'm going to go ahead and derive it. dA dr is equal to just deriving the radius. So you're only deriving with respect to r. Remember that pi is simply a constant number. So this gives me 2 times 2 4 pi or plus minus 1 times 2000 or minus 1, which gives me minus 2. This leaves me with dA dor as 4 pi or minus 2000 or to the minus 2. Okay, so from here I want to solve for the or the minimum value of or. In our case, we're looking for the minimum value here. So I'm going to put my equation equal to 0 and solve for my unknown. Okay, so I want to solve for or here. To solve for or, the first thing I'm going to do is change my negative exponent back to my denominator and write it as or squared. From here, it is easier to solve for our values of or. Let's multiply everything by or squared to get rid of the denominator. This leaves us with 4 pi or times or squared minus 2000 times or squared all over or squared. Simplifying this gives me 4 pi or cubed minus 2000. From here, to solve for or, I want or on one side of the equation and everything else on the other side. Let's move my 2000 to the other side of the equal sign, and I'm left with 2000 is equal to 4 pi or cubed. I want or on its own, so I'm going to divide both sides by the value attached to the or, that's 4 pi. I'm left with 2000 all over 4 pi is equal to or cubed. I want to find my value for or now, so I cube root both sides of my equation to get rid of that cube. And I'm left with or is equal to cube root of 2000 all over 4 pi. You can leave it in this form if you like, or we can put it into our calculators and see what this simplifies to be. Cube root of 2000 divided by 4 pi leaves me with a radius of 5.42. So the dimensions of my can must be 5.42. Okay, so now I find my dimensions for the radius. I must also find the dimensions for my height. So going back up to part 1, our height was equal to 1000 divided by pi r squared. Substituting in the minimum radius to find our minimum height gives us 1000 divided by pi times 5.42 squared. Our height is equal to 1000 divided by pi times 5.42 squared, which is equal to a height of 10.84. And I think both of these values are in centimeters cubed, because at the start of the question we found our volume in centimeters cubed. Therefore, our radius is in centimeters and our height is also in centimeters. So our two dimensions are 5.42 as the minimum radius and 10.84 as the minimum height, which provides the minimum amount of metal we need to have a volume of 1000 centimeters cubed.